Hello everyone, I'm Dr. Regina Anandi, Assistant Professor, Department of Artificial Intelligence and Data Science. Today we are focusing on an important aspect of working with databases in Node.js, Mongoose queries and populations. So in any application, simply storing data is not enough. We need efficient ways to retrieve specific data and also manage relationship between different data entities. So these two concepts, queries and populations, are essential for building scalable and real-world applications, especially when dealing with relational data in an NoSQL environment. In this session, we will understand how queries work, how population stimulates relationship, and how both can be used together efficiently. Let's start this with a quick recap on the basis. Let's begin with a quick recap. So the foundational concept in the Mongoose. First, schemas. A schema defines the structure of our documents. It specifies fields types, validation rule, and default values. Think of it as a blueprint that enforces consistency in how data is stored in a collection. Next, models. Models are constructed, compiled from schemas. They act as an interface through which we interact with the databases. Whenever we create, read, update, or delete documents, we do it through the models. So finally, queries. Queries are an operations that allows us to retrieve, filter, update, or delete data. So now looking at the architecture on the right, the schema defines the structure. The model wraps the schema. All queries execute through the models. For example, we define a schema, compile it into one model, and then use something like user.find to retrieve the data. So now we have reviewed the basics. Let's understand the core problem we are trying to solve. First, data retrieval. Modern application requires flexible and efficient ways to search and retrieve data. Users expect fast responses even when the datasets are large and queries are dynamic. Second, data relationships. Even though MongoDB is a NoSQL database, real-world data is often relational. For example, users create posts have comments, and so on. These relationships must still be represented as managed efficiently. Third, performance needs. Development needs to handle relationships in complex queries without sacrificing performance. Traditional joins can be expensive, so we need optimized mechanisms that work with the document-based architecture. These challenges set the stage for why Mongoose provides advanced queries and population features. Let's define two critical concepts that addresses these challenges, query and population. A query is a command used to retrieve or manipulate data from the databases. For example, using user.find, we can fetch users older than 18. Queries allows precise filtering based on condition. On the other hand, population is a Mongoose specific feature used to stimulate joins. Instead of manually combine data from different collection, population automatically replace referenced IDs with the actual documents. So for example, here populate author will replace an author ID with a full author document. So in the summary, queries helps us to find the right data. Populations help us to connect related data across collections. Let's now look at some basic query operations. First, user.find. This retrieves all documents that matches a condition. If no condition is provided, it returns all documents in the collection as an array. Second, the user find one. This returns the first documents that matches the query. It's specifically useful and working with unique fields like email. Third, user finds by ID. This retrieves a document using its unique object ID. It's the most direct way to fetch a specific record. Now let's refine our queries using filtering, sorting, and optimization technique. First, filtering conditions. We pass an object into find method to specify criteria. For example, age 25 returns users who are exactly 25 years old. Second, sorting. Using sort dot sort method, we can control the order of result. A value of 1 sorts is ascending order while -1 sorts in descending order. For example, sorting users by age from oldest to youngest. Third, projection and limits. Projection allows us to select only specific fields, reducing unnecessary data transfer. For example, returning only name and age. The limit function restricts the number of results, which is important for performance and pagination. So in this example, we filter user by age, sort them in descending order, then limit the results and only returns the selected fields. Now let's look at how we model relationships in MongoDB using Mongoose. This is done through reference schemas. In NoSQL databases, we don't use traditional joins like SQL. Instead, we store references between documents and using the object IDs. For example, consider a post schema that has an author field. Instead of embedding the entire user object, we store a reference like things like author field holds an object ID. That object ID points to a document in a user collection. And this particular approach keeps our data normalized and avoid duplications. So conceptually, one collection stores data, stores users. Another collection stores post. The post references user via an ID. Now that we have references, we need a way to actually retrieve related data. So this is where population comes in. Population is a Mongoose features that replace referenced object IDs with actual documents. For example, if a post has an author field, storing user ID, collecting populate author will look up the corresponding user document, replace the ID with full user details. So instead of just seeing author 1, 2, 3, 4, 5, we get author, name, alias, email, and so on. So this effectively stimulates the join operations, but in a way that fits MongoDB's document model. Let's move into more advanced queries technique that gives a finer control over the data retrieval. First, we can use the comparison operators like greater than, less than, match values in an array. For example, user finds age greater than 18. Second, we can combine multiple conditions using logical operators like AND operator or operator. This allows us to build a complex filters based on multiple criteria. Third, we can chain query helpers. We can chain the query helpers. Select method to choose field, limit to restrict result, skip for pagination. We also combine these with populations. For example, post, find method, populate author, limit 10. These advanced techniques are essential when building real-world application when queries must be both precise and efficient. In a social media platform, data is distributed across collections such as user, post, and comments. Relationships are maintained using object ID references. For example, each post stores the references to its author. Data retrieval revolves querying post, then using population to replace author IDs with actual user details. Additional relationships such as comments on post can also be resolved similarly. So to ensure performance, queries are optimized using filtering, sorting, and field selection and pagination through limits. So this demonstrates how Mongoose integrates schemas, queries, and populations to efficiently manage relational data with the NoSQL architecture. Now we'll quickly summarize. We started with schemas and models with define and structure of data, then explored queries, which allows us to retrieve and manipulate data efficiently. Next, we addressed data relationship using reference schemas and populations, which stimulates joins in MongoDB. We also looked at filtering, sorting, and advanced queries, which helps refine and optimize data retrieval. Finally, through a real-world case study, we saw how all these concepts come together in a scalable application. So Mongoose provides a powerful abstraction layer that makes working with MongoDB structured, efficient, and scalable. From defining data to querying and connecting it, everything flows through schemas, models, and queries. Thank you so much.